Welcome to this class on aspects about product and production, part 2. This is the second class out of these 4 classes about product and production within the technical analysis micro topic. The outline shows 2 main arguments. The first one is the study of materials and energy balance. So as we will see, the idea of balance is crucial when it comes to product and production analysis and product and production related aspects. And this balance, as we will see, will be referred both to the materials and to energy consumption. The second item is the study of materials and suppliers. So once we're familiar with the idea of balance, we will deal with the specifications about materials and suppliers. Today we will end our classes with the specification of a list of sub-items and a field of application of such items. So as we will do in the next classes as well, we will finish our class with a list of elements of attentions and a field of application. Let's start with the first item. Study of materials and energy balance. As I was telling you, balance is a very important element since it's very important for the project analyst and for the designer. Let's start with the energy balance. So, energy, as we know, can neither be created nor destroyed. It cannot just be converted from one form to another form. Energy is very difficult to store as well. So we might have some experiences of storage, but basically the energy which is going to be generated has to be consumed instantaneously. Then we should consider the unit operations. The issue here is to minimize the investment and the operation costs. The material flows, so everything which is transforming input into outputs, so raw materials and other materials into products. The energy flows, with the idea that I was just recalling, and the product flows, so everything that goes from the product manufacturing to the sales networks. So when it comes to the materials balance, it's about materials flowing into the project are either consumed in production of primary products and byproducts or become wastes that must be disposed. So it's the transformation of the inputs into outputs. We have products, byproducts, and wastes. So the plant configuration and the production plan should consider not only the main products or the car products, but also the byproducts and the wastes and their treatment. So we have a material flow balance, as well as wastes and effluents balance. When it comes to wastes and effluents, as we will see in our last class of this module of technical analysis, we have very important environmental concern and additional costs. So it's not only the storage or the treatment of such wastes, but it's also the fact that those elements should be disposed, and this disposition could be very costly for the organization. Energy balance on the contrary, is the energy that flows in an investment project and have an effect on investment and profitability in a number of ways. Read costs. So energy should be generated and it's going to be absorbed by the project, and the way which is absorbed in a more or less efficient way generates costs for the project management. So what we should consider: conversion opportunities to begin with. So energy could be just converted. So the most efficient use of the energy within a project is the reutilization of the same sources for different outputs. It's the exploitation of the so-called economies of scale through the combination of different outputs having the same source of energies. So the reutilization of energetic resources, as well as the combination of different outcomes associated to the same energy source, it's a workable way to exploit the conversion opportunities as well. Backup plans. So in case of energy disruption, the plant could be, and the production itself could be compromised. So it's important to have backup plans in order to maintain or in order to support the operativity of the plant without compromising the production itself. So the continuity of the supply of energy is crucial to the plant itself. Efficient use of energy, which is another element that we are familiar with, and the in-plant storage solution. So as I was saying, energy is difficult to get stored, but we could build up some storage units for specific sources of energies. So the idea of balance is crucial, as we were saying. So balancing production and the dynamic analysis. Dynamic analysis is applicable when demand is cyclical, and we could consider some parameters. So if demand is cyclical, we've seen already that we assume that demand has its own cycles, and we are able to predict or detect these kind of cycles. So in such an hypothesis, leaving such an hypothesis, what are the parameters that we should take in consideration? Well, the production level, either the actual or the predicted production level, is the first parameter that could help us to define the energy balance. Second, the production cost. Again, either the actual or the estimation of such cost. The setup costs. What are setup costs? If we have one plant which is specific for one production, and this only production has no possible variations, well, then it's very easy to set up the machinery and the equipment and to keep the production going as long as we decide to change the production itself. But if the plant is a multi-purpose plant and we have within the same plant we are able to develop and manufacture different products, then or different variants of the same product, it could be possible that in between the production of one product A and another product B, we might be exposed to some setup times. So setup times imply setup costs as well, since they might be associated with the installation of new materials or the refurbishment of the equipments with other supplies and things like that. So everything which is related to the setup time and operations could absorb resources and in turn create setup costs. The holding cost of inventory. This is another important element. So inventory means storage, and storage is expensive. Now, what are the holding costs of the inventory related to? Well, first of all, we have the risk of perishment of our raw materials, which is costly for the company and the project. We might insure that cost, but then we have an insurance policy to be covered, which is part of cost as well. The space we're using is expensive by definition. Locations being property or landing facilities of the company are expensive in both cases. So we have an amount of cost which is related to the storage of any element. Third, cost of lost sales. So if the energy disruption, for example, is compromising the productions, we are losing sales on the market. This cost could be estimated as well. The outcome of such a balance is the so-called least cost production program, which leads to the optimal plant capacity. So the idea of a balance, both balancing materials and energy, implies to optimize the plant capacity. So the least cost production program, as we will see, it's a program which is based on the idea that we are able to minimize the operational costs and associate this optimal configuration to a specific plant, both in terms of layout and capacity, as we will see. So the optimal plant capacity, it's about the exploitation at the maximum level of the installed capacity without losing additional resources in terms of inefficiency or less productive activities. So the idea of balance, it's an idea of being exposed to a compromise between the optimal use and the actual use, and the idea is to maximize the exploitation of any resources involved in the production plan, and plant capacity is a crucial element of economies of scale, as we will see. When it comes to the study of materials and suppliers, we should consider both the materials in their nature and the role of supplies and suppliers. So the project inputs are either materials or supplies. Materials could be of any kind of natural form, solids, liquids, gases, of any combinations of these elements. Let's go through a materials and supplies classification. We might have raw materials, like iron or copper, for example. It's just something which has been extracted or harvested or created in a raw shape. Then we have the so-called processed industrial intermediates. So if iron is the raw material, steel, for example, is an industrial intermediate. So if you have steel forms, for example, something which is obtained by an industrial product, but still has to be refined and reshaped and recombined in order to obtain a final product. Then we have manufactured materials and parts, like tires, for example, or dyes, or any artifact which is a component of together with other parts, is just a component of a complex final product. Then we have the so-called auxiliary materials, which are incidental to the production process. So, for example, lubricants, oils, and solvents that could be used in the production process without being the core elements of the product itself. Then we have factory supplies like maintenance, for example. Then we have the utilities, fuel, water, energy, that often comes from an infrastructure to which the plant should be connected or plugged. Spare parts are very important because if we have equipments and machineries and maintenance is crucial for these equipments and machinery, the company itself should store some spare parts in order to reduce the intervention time in terms of ordinary and extraordinary maintenance. Modules, dies, and other special tools. So tools are another important element of this materials and supplies classification. Once we have classified the materials and supplies, we should proceed to the analysis of materials and supplies. This analysis could be conducted both in qualitative terms and in quantitative terms. So in terms of quality, we might refer to industrial standards, which is for example, the referral to national or international standards, or the regional standards, or the industry-related standards, considering the field and the environment where the plant is operating in. And when it comes to standards related to quality, it's about, for example, the composition of the materials and suppliers, or the purity. Let's think about the raw materials, for example, and or the performance specifications. So materials, which are the input for the plant, could be classified in terms of standards according to different elements, to different perspectives. Second, we have the alternatives, the substitute for the materials. So to some extent, whatever the nature of the material is, we might refer to different types of the same materials, to different levels of specifications and performance of the same material. So, for example, if you consider the purity of a raw material, the higher is the purity, the lower might be the number of discarded final products. So the company itself could have a different range of purity of the same raw material connected to the expected quality of the product itself. Just to recall the idea, the production program, which is by which the analysis of materials and supplies is just one part, is related to the sales program, which is related to the marketing program. So the definition of the final quality of the product is not independent from the strategic choices which have been made within the marketing program, as we've seen already during our past classes. Third, tests. We might have laboratory tests for some raw materials, or we could test the raw materials or whatever materials and supplies in other plants which are similar to the one we're going to build up. So if the plant is not existing already, it's difficult to test, well, it's impossible to test the materials in the actual production activities. So we should either refer to some laboratory experiments for testing the materials, or we should process the same materials in a different plant. When it comes to quantity, we should refer to the process requirements. We should take account for losses as well. So, as we will see, not everything which is processed in a company or in in the plan is optimal product in terms of outcome. We have some wastes as well. We have some byproducts. We have some wrong production occasions as well. So we should take account for losses. Supplies program and schedule. So considering the schedule of the supplies, we should consider the amount of storage, the internal storage of such materials as well. So it's not just the requirements in terms of quality specifications, it's not only the process requirements in terms of quantity, it's also about the schedule of the supplier. So according to the deal connecting the suppliers and the client's activities, the quantity of materials and supplies is connected to these deals as well. Then we have the storage of such materials and supplies. So ultimately, the considerations of quality and quantity in terms of requirements define the cost of our materials and supplies. So when it comes to cost, we have another sub-element to be taken in consideration, which is the project inputs and the pricing issues. So we might refer to the price history and forecast. So each industry has its own historical data, and considering the historical data and the general economic conditions in terms of fluctuation, we might be able to forecast the prices of raw materials. So during the module related to the marketing, we've seen how to forecast the demand. The exact same methods could be used for the estimation of the future price of materials and supplies as well. Another additional element is inflation and price escalation, for example. Then we should consider seasonal cyclical variations of such prices. We should consider the price mechanism, and we will go back to this point momentarily. And we should consider the exchange rate projections for imports, for example. So if we are importing raw materials from a specific country and this country is not adopting the same currency as ours, we should also consider the exchange rate between the two or more currencies. So it's not just about the cost of the specific material, it's also about the price of the currency related to the specific material. Also, we should consider the take or pay contracts. So if we have a long-term deal, the price could be fixed and embedded and determined by the contract rather than by external elements. We should consider the reliability of suppliers. So the higher the reliability, the lower could be the actual cost for the project and for the company. If the supplier is not reliable, then the cost could be higher for the company. Capital binding and distribution channels, as well as the learning curve, meaning that if we learn how to deal with the supplier, and if we learn how to employ our materials and supplies within the production activities, then we could learn how to waste less of them and be more productive and more efficient at the same time. So, since suppliers and the materials are an important part of the production process, we should plan them as well as we do with all the other activities. So, we have a supply program components made of quantities and sources. Sources may be domestic or import. So the distinction between domestic and import is not just about the nature of our supplier. but calls for an analysis of the distance between the different locations. So it's not just price of the single component, it's also about the costs which are closely related to this kind of supply. Again, when it comes to the supply program components, we have quantities, sources, specifications, price, and transport and handling conditions. So we should consider all these elements, we should program all these elements. A way for obtaining a supply program components is to schedule these activities and to obtain a collection of information that should be systematically collected and organized by the company. So we should collect some data about materials and supply, so materials and supply data, such as number of code, unit of measurement, payment terms, the order quantity to be fixed by the company which is carrying out the project, the minimum stock of such materials which is fixed by the company in terms of with the aim of securing the production process. So companies should have at their own disposal a minimum quantity of materials and supplies in order to avoid the out-of-stock situation that could compromise and interrupt the production process. Minimum days coverage, which is the equivalent of days for the security stocks. Storage requirements, environmental, physical, like temperatures and things like that. The lead time, which is the time for purchasing the material and obtaining the transformation of it. The specification of sources and the quantity per production unit. So what is the absorption of such material supply by the single product? Additionally, we have to include price, market, production item, which are related to these materials and supplies, standards, classifications, if any. The waste factor is very important since, as we were saying, there is a difference between the nominal and the feasible usage of materials and supplies. So, according to our level of productivity or reliability of our plant, we should operate on this waste factor as well. Then we have the yield factor, which is the quantity per unit. The yield factor is an element which is culturally coming from the agriculture. So the yield is just the return of the asset in terms of seeding and then the production. When we consider industrial plants, the yield is the return in terms of productivity considering normal standard conditions. Supplies program. As well as the materials and energy, we have a supplies program which is made of the elements that we've seen so far, and is going to help the company structure its production process and its production installation. So the supplies program specifies the timing of purchase, i.e., how much will be needed in each production period. So it's basically a schedule of procurement and purchasing of such materials, and it's obtained by the calculation of the least cost operation cost hypothesis. So the supply program is based also on the price structure. This is one element that we were considering before. So when determining the cost of project inputs, it is sometimes necessary to take into account the structure of pricing in the supplier industry. So it's not just about supplies, it's about the analysis of suppliers as well, and their competitive conditions and their pricing structure as well. So it's not just about the input, but it's also about the company or the similar companies which are delivering such an input. So just to have an idea of what and how the pricing structure could work, if we consider this example of pricing structure, we have the annual cost of electricity, for example. So we have a pricing structure that we're going to depict as an example, and we choose electricity as an input for the production process. Electricity, as you know, is a very important utility for any production process if it's industrialized production. So the cost of the electricity per year could be considered as the sum of CF, fixed charge, plus CE, energy cost. So to begin with, if we consider the annual cost of electricity, we might have two elements. A fixed component, let's say a fee that we pay to the supplier for getting connected to the infrastructure, and then the actual consumption of electricity. So we might have a fixed and a variable cost, or better, a fixed and a variable component of the same cost. When it comes to the energy cost, which is the actual consumption, which is the variable cost, again, the supplier could utilize this structure for pricing. Let's see it in details. So CE, again, it's the same component that we've seen already. It's the cost for the energy consumption in the year, which equals to CEP times EP plus CEO times EO. Now, P and O stands for the difference between the so-called peak hours and off-peak hours. So in the energy industry, it's quite frequent that suppliers could differentiate the prices between the peak hours and the off-peak hours. So let's assume that CEP, which is the cost, the unit cost of energy during peak hours, is higher than the unit cost of energy during off-peak hours. So the company which is absorbing energy, electricity, is exposed to two volumes of consumption, EO and EP, whereas EO is peak energy consumption and EP, similarly, is the off-peak energy consumption. So we have prices here, CEP and CEO, and quantities, volumes, EO and EPs. So the general cost, which is the variable part of the cost of energy that we're seeing, CE is just the sum of price times quantity, both for peak hours and off-peak hours. If the company is aware of this difference, and if the difference between the delta, the difference between CEP and CEO is large, then the production process should embed this price structure and schedule the activities accordingly. So, to this extent, it could be more convenient to concentrate the productions in the off-peak hours rather than in the peak hours. So, let's conclude this class with the exploration on what should be done and what is the field of application. As I was recalling in the beginning of this class, for these three classes about production and product, we will end our classes with a list of elements that should be taken in consideration and a field of application. So, in order to summarize our contents, production cost estimates, when it comes to materials and supplies, includes a list of several items. Specifically, item number or code. So for each material and supplies, we should use a specific code. Quantity, unit of measurement that, as we've seen, could change from country to country according to the national or international standards. Market, unit cost, and total cost per period. So, in terms of items, the production cost estimates related to supplies and materials should include all these elements. What is the application? The application is specular to the classification of materials we have done during the first part of this module about production definition. So, during last class, we've seen that we could classify the materials in terms of raw materials, unprocessed materials, semi-processed materials, components and subsystems, auxiliary materials, factor supplies, and utilities. So we have a list of elements that we should take in consideration, and these elements are able to help company to picture what is the actual cost of, or the estimated cost of materials and supplies. And then we should adopt the very same formula, the very same scheme for covering the whole range of materials and supplies that we're buying as a company and employing in our production process. For further information, you can refer as usual to our website. That's everything for today. Thank you.